Welcome everyone. So this is the part 2 of the crude oil distillation. So in this part we are going to be running the simulation to continue from where we stop, and then we are trying to achieve the separation of the crude oil into different um, components. Alright, that's the diesel, the kerosene, the AGO, naphtha, off gas and all. So remember, we are trying to use a particular journal for this simulation. um, Now we are about to go into the distillation tower, that's the distillation column. But now there's a twist to this. Now if you're looking at this, you think that it's the regular distillation column you're supposed to use, but there is something up here now. Now take note of the energy stream, which is this condenser. Now this condenser is actually um, this Q condenser, actually it's the energy stream for our condenser, right? And then looking at everything here, we don't have another energy stream for the reboiler. Alright, so with all of this, it's just trying to let you know that this is not your regular distillation column, but this is a reflux absorber. Alright, so it is the reflux absorber we're going to be using to simulate this. Alright, so now going forward, we are not going to be using all the parameters from here because looking at them, some of them are having issues. Alright, so we're going to be using from another source. Alright, just follow up with what I'm doing, and then at the end of the day I'm just going to pick out some things from here, and then we're going to use it to complete the simulation. Alright, so I'm going to be making use of all of this, the steam for it, and then you see where the steam are going to be coming in. I'm going to be making use of all the steam, um, and then at the end of the day I'm going to be picking out all the products and then simulating to see the result for them. Alright, so now let's go forward. Alright, let's go forward. So let's start the simulation. So I'm going with the reflux absorber. Alright, and then now this particular journal, they have total number of trees 29, so we're going to make use of that. Total number of tree we're going to be using is going to be 29. Alright, so make use of 29. Make use of 29. Alright, we're supposed to add an energy stream. Now looking at what we have here, we have the Q trim going in, which is an energy stream, so we're going to select that too. We're supposed to add that, sorry. I'm going to close this and then add the energy stream. Call this Q trim. Alright, okay, let's duplicate. Oh, I already have one there already, so I'm just going to delete this. Alright, so this is the Q trim. Okay, so now this is where we're going to twist it. Now in that particular journal, their stage was 27, but we're going to make use of stage of 28 for this, so just follow up stage 28. Alright, and then the Q trim and the energy and the feed are going in at the same stage, so 28, 28. Now we have the main steam, which is going to be like the heating source for this. So we have the main steam going in at the bottom. Alright, call this the distillation tower, distillation column. Okay, now I'm going to name this as con Q. They used Q condenser in theirs. I'm just naming mine as con Q. At the top here we have off gas. Alright, at this part we have naphtha. Okay, then we have the optional side draw. This is also part of what we have here. See, we've added the off gas, we have the naphtha. Now we have the water wastewater, which is going to be the optional side draw. Okay, so just going to add that. I'm going to put wastewater here. Alright, we have W, change the type to W to mean water, and then this is coming out from the condenser. Okay, then we have this as the residue. Alright, so checking what we have here, I think everything is it's all in check. Residue, okay, so it's just the diesel, kerosene, the AGO that we need to get later on. So alright, so from here now, what we're going to do, click on next. Okay, now this is where we're going to be changing parameters. So for this particular one, I'm going to be making use of my compressor, my condenser pressure. Alright, it's going to be 19.70 psia. Okay, there's going to be a condenser pressure drop. Now they didn't have a condenser pressure drop in theirs, but we have a condenser pressure drop of 9 psi. Okay, 9 psi. Alright. We're going to make use of the bottom pressure as 32.70, still in psi. Alright, so the condenser temperature is going to be 100 Fahrenheit, so we leave that. The top stage pressure is going to be 250 Fahrenheit. So we have the temperature at 700 Fahrenheit. Okay, the vapor rate is going to be 0. We change this to mass, and then we're going to work in the reflux ratio of 1. Alright, so this is actually the same thing what they have in theirs, still 0 0, and then we have the reflux ratio different. They didn't specify the basis of their mass of their own reflux ratio, but we had to specify this as the volume. Alright, so from here we go to the side ops, click on side stripper. Now this is going to be serving as the reboiler stream for this particular unit. Alright, because of we are going to be using the reboiled side strip to get our kerosene, so this is going to be kero SS, and then the kerosene is going to be product is kerosene. Alright, and then now we're going to be using the return stage. Return stage for this is going to be 9, and then the return stage is going to be 8, draw stage is going to be 9. Okay, click on install, go to next. Now I'm going to be adding the steam strip. Now our diesel and kerosene are going to be steam stripped, so we're going to make use of the diesel first. Diesel, I'm going to have the diesel steam. Alright, so and then the product is going to be diesel. Alright, now we're going to be looking at the return stage. Return stage for our diesel is going to be 16, and the draw stage is going to be 17, and then we leave it like that. So go to install, add the next one. Remember I said the both of them are going to be steam stripped. Now this is going to be AGO steam. Alright, and then the product is going to be AGO. For this, we're going to be using um, return stage is going to be 21, and the draw stage is going to be 22. Okay, click on install. Next. Now we need to add the pump around. Alright, remember they added the pump around in theirs too, so we need to add the pump around in our own. And then the pump around, the first one is going to be the return stage of 1. Theirs was return stage of 2. So you can just see just few changes. Alright, add another one. The pump around 2, the return stage, ours is 16. Our return stage is 16. 16, draw stage is 17. Alright, and then the last one, we have the return stage of 22. Okay, return stage of 23, 21, and the draw stage of 22. Alright, so click on install. We're done with that. So just having 3 pump arounds, and then go to next. Alright, so for this now, we are going to make use of the draw spec for our kerosene. We are going to make use of 13,000 barrel per day. So click on next. For the diesel, we are going to be having a draw spec of 1.7 E4, which is actually 17,000 barrel, and the AGO is just going to be 5,000. Now if we even look at theirs, their AGO is the least there. Alright, so just using 5,000 barrels per day. Okay, so now coming to the pump around. Now our pump around, the first one is going to be 50,000 barrel per day. The P2, that's pump around 2, is going to be 3E4, 30,000, and this also is also going to be 30,000. So alright, now we have duty. Now in theirs they had to use the return temperature. Alright, and then if you want to get the return temperature, you just click on this, you see return temperature, but we're making use of duty for this one. Alright, so the duty we are going to be making use of here is going to be, this is going to be minus 55E6, and it's going to be in BTU per hour. Alright, this is going to be minus 3.5E7 BTU per hour, and the last one is going to be minus 3.5 E7, still in BTU per hour. Alright, so moving on, we have the HYSYS. We're not having any of this, we're not adding this, just keep moving till we are done. Alright, so now the next thing we're going to do now is to, let's bring this up. Alright, so go back to our monitor, and then we add 2 specifications to it. So we're going to be using the column liquid draw rate, and then this is going to be at stage 27 with the specification of 3,500 barrels per day, and then now this wasn't given in there, so we have another one for duty. Okay, and so their duty, the duty was given, but they didn't specify that it was going to be for the HYSYS. Alright, but I feel that is what they were trying to achieve in theirs, but we're going to be making use of 7.5e raised to the power 6, and then we're going to be using BTU per hour. Alright, now our draw rate is going to be 2E4 for the distillate rate. Okay, so what we're going to be doing now, we're going to be taking off the reflux ratio, we're going to be taking off the boil up ratio, we're going to activate the vapor product rate, and then we're going to activate duty. Okay, not enough. Okay, so I'm going to take this back off. We've not yet specified our steam yet, so I'll come back to this and specify all of this, but let's get back to our steam. Now we have steams going in. Remember I told you we're going to be making use of okay, just so I can separate it properly. Alright, so the main steam, okay, I'm going to be getting the specification from their work. Alright, the main steam we have, okay, 174.7 and flow rate of 4000. Okay, main steam 174.7, they all have the same, and then we're going to be making use of the mass flow rate of 10,000. So this is what I'm going to do. Vapor fraction is going to be 1. Temperature wasn't given, that's why I specified the vapor fraction. This is 74.7, if I'm not mistaken, 74.7 psia. Alright, and then the mass flow for this is 10,000 10,000 pounds per hour. So make this 10,000 pounds per hour. Alright, that is my specification for. Okay, then we need to add the, remember this is steam, so technically water is 1. Alright, so this is good to go. So I'm going to be doing the same thing for diesel steam. Alright, so for diesel, still going to be 1. The pressure is 74.7 kPa, psi, sorry, and then the mass flow for diesel steam is 4,500 pounds per hour. So pounds per hour. Okay, and then steam making water 1. Alright, and the last thing is the AGO steam. AGO steam, we have vapor fraction 1, pressure 74.7 psi, sorry, and then the mass flow is 4,000, and then this is going to be in pounds per hour. Here we go, making this 1. Alright, okay, so now we can return back to our distillation column and then finish up. So right here, distillate rate, yes, vapor rate, yes, we took out this, and then we're going to activate the last one. Alright, so the system is converged right now. Alright, so now we're just going to be changing some of the parameters to fit what they have there. So we're just going to be checking a few things. Now they had something about the efficiency. So let me try and add efficiency here. Let's see how that goes. So I'm going to be having 0.8 efficiency. Okay. Alright, system is still working very fine. Okay, they gave reasons why the efficiency is 0.8. Um, because in standard ideal, okay, the overall stages was 80% because the column efficiency of industrial trays column is what, 60 to 90%, so left it at 80%. Alright, then we're going to look at the, let's just change some of this. Now this is the result they got for theirs, so let's see how we're trying to get this. Let's impute all of this and see if we're going to be getting the same thing. So for the diesel, we're going to put 2 times 10 raised to the power 4, and then let's see the result. So basically the major changes that affected this whole simulation is the positioning of the pump around the stage, the inlet, the return stage, the draw stage, then the duty. We use the duty for the pump around. So these are those basic few things we changed in this. Then theirs didn't have the temperature for the top stage, condenser, and the reboiler. Alright, so we had to get all of that and add it to it. um, there was no pressure drop in their own from the condenser to the top stage, right? So those are just a few things we changed in it, right? So I was talking about the kerosene, the product flow rate. So we're going to be using 2E4, right? So 2E4, yeah, 2E4, and let's see, do we still have results? Still converged, everything is working fine. The AGO product, we have 2.38 e raised to the power of 3, so that's going to be 2.38 e raised to the power of 3. Alright, everything is still going well. um, the kerosene, can change that, and then what they have here, 3.14 e raised to the power of 4, so put 3.14 e4. So still in perfect conditions. Alright, so everything is working fine, everything is alright. It's just the temperature we changed. Few things we changed: temperature, pressure, and then the feed trays, and just few other things, right? So basically that is it for this simulation. um, there's a lot to still discuss on this. You need to check the internals, do some ratings, check some other conditions, so that is exclusive for the students. All right, so see you all in the next session. Bye for now.